All right, this is video 7.2.2, and we're going to be still working on the writing and interpreting models, but we're going to be focusing on variation equations. So I've got just a couple examples. Let's go ahead and go through them. So direct variation should be a review. Remember, this is of the form y equals k times x, where k serves as our constant of variation. So just another practice problem on this. If y varies directly with x, so y equals kx comes from the first sentence. If y equals 35 when x equals 7, we need to find y when x equals 9. Which means I have to find out what the k value equals. In this case, it's 5. So 5 times 9, so y equals 45, and that's the process. Let's take a look at another one. So this is inverse variation. An inverse variation is y equals k divided by x. You can remember that it's k divided by x because direct is multiplication and the inverse of multiplication is division. So y equals k divided by x. So this first sentence sets us up. Y equals k over x. If y equals 9 when x equals 4, that's what we want to do, then we need to find out what y equals when x equals negative 2. So that is, we have to find out what k is first. In this case, you multiply both sides and we get k to equal 36. We substitute in the 36 and y equals negative 18. Okay, so here's an application for using inverse variation. Okay, so again, we're still using inverse variation, but this time we're going to be using the variables that make sense for this particular situation. The current in a simple electrical circuit varies inversely. So the current is what's varying inversely as the resistance. So instead of y varying inversely as x, we have the current varying inversely as the resistance. If the current is 50 amps, when the resistance is 10 ohms, then we need to find the current when the resistance is 5. So we have to find our constant of variation. And we'd multiply in this case by 10. And that gives me k equals 500. So we can put in a 500. And then we find out that the current is 100. And the label for the current is amps. So 100 amps. Let's try another one. This one is called joint variation. And joint variation simply means that we can use multiple strings of variation, often using products, so multiplication. So y equals k times x times w times z times whatever number of variables that we're given. Okay, so if q varies jointly with x and y squared, that's different. So q is varying jointly, so I'll put in my constant of variation with x and y squared. Okay, so now I'm going to set it up that q equals 200 when x equals 4 and y equals 5. I should put a 5 in there, not the y. Oh boy. Let's erase it. What a mess. 5 squared. So let's go ahead and simplify this. If you need your calculators, please grab them. But 200 equals k times, this is 25 times 4, which is 100. So it looks like we got k equals 2. Now we're going to use that to find q. So I've got 2 for the k. Okay, I'm still using this. X is negative 3. And y is, I put a y in there again. Y is 4. So I've got 4 squared. So once again, grab your calculator if you need to. This is q equals 2 times negative 3 times 16. Okay, so type that in and see what you get for q. So I've got 6. Oh, of course I grabbed the calculator that the batteries just died. I better charge that. Sorry about that. So I should have 6 times 16, or negative 6 times 16. So q equals negative 96. All right. All right, so now we're going to try to pull it together and take a look at a couple more applications. For our first example, it's going to talk about the area of a triangle. And your first instinct is, I know the formula for the area of a triangle. But what I want you to do actually is I want you to work through it the way it's written and ignore that you have some previous knowledge about the area of a triangle. So the area of a triangle varies jointly. So area is varying jointly as the length of the base, base, and the height. So I've got area is going to vary with the base and the height. And I know that you know what K is going to be, but let's actually prove it. A triangle with base 10 and a height of 4 has an area of 20. So if you were to multiply this out, you would get 20 equals K times 40, or K equals a half, which should not surprise you. So we need to find the area, putting in the K value, putting in the base, and putting in the height. Okay, so then this will tell us what the area is going to be. So if you multiply that together, you should get an area of 12 feet squared. Now remember, I know you know the area of a triangle formula. So this one worked out, and we could have done it without this system. But the point is that we know where to substitute numbers in so that we can find anything, including formulas that we don't know. So let's take a look at the next one. W is varying directly as x, but inversely as the square root of m. Let's write it down. W varies directly, so there's my K, as x, but inversely as the square root of m. Okay? If W is 30, when x equals 3 and m equals 16, okay, let's start that. So I'm going to simplify this. And I'm going to first simplify the square root of 16 to be 4. So I have 30 equals K times 3 over 4. I'm going to multiply by 4 and then divide by 3. So if I multiply by 4, I get 120. If I divide by 3, I get K to equal 40. So now I'm going to substitute it back in. So I'm going to say W equals K is the 40, my new x is negative 2, and my new m is 81, and it's in the square root. So now that you can simplify that, you get W equals negative 80 over 9. And there's no better way to write that other than negative 80 over 9. All right, great job.